Today we discuss about the mechanism of size reduction, and this is my presentation topics. At first I tell about the size reduction. Size reduction is such type of process where we reduce the particle size for several reasons just as to increase the bioavailability of the pharmaceutical products and to desired shape and desired dissolution. Several theory or several method are developed for size reduction purposes. Here the table will show cutting, compression, impact, attrition. By this method, several equipment are used to do this to follow this method, such as for cutting purposes we use cutter mill, for compression purposes we use roller mill, for impact we use hammer mill, for attrition we use ball mill or several other equipment. Here it shows two figures on the mechanism of size reduction, and here's the diagram. In this figure we can see that the before impact at the initial stage of the particle at this condition. Now the impact energy when we produce energy or when we apply energy in this particle, that time we find this type of material. Then after first impact we get this, and then after multiple impact we get this fine particle. From this stage if we apply pressure, that time large process of zone is required to get this fine particle, and from this if we apply, that time a small process zone is required to find this particle. And here the changes particle size, the particle diameter, the passing time, the particle size, and the milling time. When the milling time increases and the particle size gradually increase and decreases, so milling time and particle diameter inversely proportional to each other. Now I discuss about these four topics: cutting, compression, impact, and attrition. Cutting, such type of process where we cut the particle just like the nibs, stationary nibs and rotatory nibs. When we apply the product in this situation, the time the nibs are rotated and cut the particle at the desirable feature. Here the diameter 100 diameter micrometer to 1 lakh we can get by using the machine. And the particle diameter and percentage of frequency. At the frequency will show that the for the initial stage of the particle diameter is very high, but after passing time when we apply cutting, that time we get a small particle that are related to this particle, and when this the frequency is fall down. Now compression. Compression such type of process where the two rotatory device, first pair of roll, second pair of roll, second roll pair, but at initial stage they are compressed, and the final stage second time they are compressed. They are rotated to each other. Beyond two is not equal, and here the particle diameter at initial stage first pair The particle size is not too small, but when the second steps they overcome that time size reduce. Now the impact, and the main equipment is hammer mill. Hammer mill, here the product is pitted and it is rotated. After rotate, it's called hammer. Rotating time the product we get, and this desirable size hammer will get the product size 1000 micrometer. And the final one is the attrition, the ball mill. Rotatory device, centrifugal force is the important term. Centrifugal force and centrifugal force movement of the supporting discs. The ball moving in the mill are affected by the gravity of the centrifugal force. Centrifugal force depend on the rotation speed of the mill. The rotation speed and the equation that we found F equal to m omega.